Hello, this is Matthew. Today it will be a little bit different from the normal lesson. Instead on teaching I will show you an example, which is in tension reinforcement for a rectangular beam section. Let's see our section first. This is the beam cross section with tension reinforcement. The question has given that the effective height of the section equals to 490 mm, and the width of the cross section equals to 230 mm. The design parameter is given as follow. The characteristic strength of concrete equals 25 N per square millimeter and the characteristic strength of steel equals 500 N per square millimeter. The design moment equals 165 kN and moment redistribution equals 0. As mentioned in the previous chapter, the K value is calculated from design moment and stress block. We should firstly to check the K value to determine whether the compression steel is required. If K is larger than 0.167, the compression steel reinforcement is required. If K is less than 0.167, the compression steel reinforcement is not needed. In our case, K equals 0.12, which means there is no compression steel reinforcement. The next step is calculating the lever arm. We can use the equation to calculate it. After substitution you will see the lever arm equals to 431 mm. Then it is important to make good use of the lever arm with the design parameters. By substituting the design parameters to the tension reinforcement equation, we can get the area of tension reinforcement needed. There are the process of substitution. You can stop the video to watch the calculation carefully. As you can see, the area required for reinforcement is equal to 880 square mm. To provide steel reinforcement, we should ensure that the area provided should be larger than the area required. For example, we provide 3 steel bars with 20 diameters for reinforcement. The area provided equals 943 square millimeters, which is larger than 880 square millimeters. As the code mentioned, the minimum steel reinforcement provided should not be less than 0.0013 BD. As you can see, our provided steel percentage is larger than the minimum percentage required. The code has also reminded that the steel area provided should not exceed 0.04 BD. We should also check the steel percentage whether the provided value is suitable or not. In final, we could check that our design is within the limited steel percentage in code. You have already learned how to design a beam section with steel reinforcement. There is another beam design exercise in the self-evaluation part. Thank you for your watching and see you in the next